Good morning, everybody. Thank you for joining us for our VIAS webinar, Highlights of Abaqus 2020 Technical Enhancements. Our webinar will be 1 hour long. We'll have a 10-minute question and answer session at the end. Our presenter today will be Subhadeep Maiti, Senior Simulation Engineer at VIAS. Subhadeep is a mechanical engineer with over 7 years of industrial experience in the field of design and numeric analysis of multiple industry products. He got his master's degree in mechanical systems design from IIT Kharagpur. Subhadeep, would you like to take over?
Yeah, sure. Thank you, Beatrice. So today's webinar name is Highlights of Abaqus 2020 Technical Updates. So this is my agenda. So I'll be giving a small introduction about our company and about the webinar agenda as well. And then we'll be going through 6 different areas where Abaqus has implemented lot many updates. So I am just concentrating much more on the highlights of the update, not all the updates, which are basically useful to maximum of the users. And then I'll be giving a quick summary of the all updates. So our company is virtual integrated analytics solutions. So we are a multiple industry experience company having experience in different domain like oil and gas, machinery, equipment, medical devices, manufacturing, and automotive. So we are having presence in Houston, that is our headquarter, and then also we are having presence in Chicago, Cincinnati, San Francisco, Detroit, and even in India as well. So our team consists of PhD and masters in different advanced areas like solid mechanics, fluid mechanics, material and corrosion, numerical analysis, optimization, reliability, and data analytics. And we are the platinum partner of Dassault Systemes, Simulia. So that means we are eligible to sell all the Dassault Systems product, including the Simulia portfolio like Abaqus, Eyesight, FEA, Tosca, CATIA, Elmia, etc. Also, we provide engineering consultancy training, sales and support, and help end user in doing a lot many automation and the customization jobs. So these are the few of the companies to whom we provide the FEA consultancy regularly. So to name few like Delphi, Cell, Exxon Mobile, etc. And in CFD, these are few of the companies as well. And in data analytics, we give a lot many solutions to Samsung, NASA, Gap, etc. Uh, we are also, as you told, like we are the reseller of the Dassault product. So that means we sell the software, Dassault softwares, the solutions to lot many customers, and we also provide trainings to few of the customers like Boeing, Schlumberger, Shell, etc. So our technical capability is basically scattered to multiple domains, and basically we are mostly in the FEA, CFD, and the data analytics. So starting from the component design and validation using simulation to the advanced areas like the fracture mechanics, the damage mechanics, and then the design optimization, reliability, and the vibration assessment, electromagnetic analysis, the fatigue analysis, composite modeling. So these things also we do. For the customers, and we do lot many automation, simulation automation tests for the end users based on their requirement. So this is our value proposition. So we are committed to every client's success to technical excellence and innovation. We have domain knowledge in FEA and expertise in multiple industry experience. Uh, Also, we can also review your existing simulation offline process and provide you feedback if it require to add any enhancement for speed and the reliability. We provide customized and standard training in-house, on-site, and online. Also, we offer software development services for Abaqus, including user subroutine, user elements, Python scripting, allowing the pre or the post-processing feature and calculation, etc. So now I'm coming to the heart of the presentation. So when we are discussing about the updates of Abaqus or updates of the Simulia products, so you need to know few of the terms. So in the last week of November, the latest version of Abaqus 2020 GA version is officially released worldwide. So when you say like golden version, that is basically known as a GA version, which is like general availability version. So DS is having some internal build level, so they called it like hot fix level. So those who are regularly using these things, so you probably know these things. So they are named like HF, FP, and the FD. So HF basically is the hotfix, so that is basically the internal build level. So like if you're seeing some bug and if you're fixing that one, so that one you basically release in the hotfix level. So typically in every 8 week, all the fix pack are contained into hotfixes, and then a new hotfix has been released in every 8 weeks, basically in the 2 months, every 2 months. And the FPs are basically assigned with a 4-digit number, like 2 year and 2 weeks. Okay, so the two end digit of the years and 2 weeks digit. So if it is like 52 weeks in a year, so it will be like if it is releasing uh, in the last month of the year, so it will be like 52. So FD stands for the functional reliability. It is basically applied to a 3D experience platform. So it's represent all the updates of the software that is validated by Dassault System and the R&D across all the technologies. So whatever the GA version of 2019 you obtained in the last 2018. So on top of that, whatever the additional hotfixes, FD and FP is applied. So those all things are combined together in the Abaqus 2020 version. On top of that, they have added a lot many new functionality. So that's why we are having this webinar where we'll be mostly concentrating on the highlights of those particular updates. So first I'll go with the Abaqus CAE updates. Many people, whoever is using Abaqus CAE, you know very well, like it is a very big pain point when you want to do multiple sweep or extrude of edges through a particular direction or through a particular edge. So it need to be like previously, every edge should not be connected together. So they should be in a chain wise. But right now this particular limitation is removed. So that means you need not to have a closed chain of the edges. So you can just select any open chain of the edges and just select the extrude direction, and that will be able to extrude the cell to create a particular kind of additional partitions. And previously we used to use like Abaqus, so we call it like SolidWorks Associative Interface SI. So now it's not required. So if you're having a SolidWorks file, you need not to convert that one to some part or IGS format. So you can directly import those files uh, in the Abaqus CAE without any associative interface, though that is involved in the background. But this is currently available on the Windows platform only, not Linux platform. So if you want to renumber nodes and assembly from assembly constraint, so assembly context, so you can select dependent native parts instance for global numbering control. You can pick orphan nodes or element from part instances for renumbering in the mesh edit toolkit, which is shown in the side by uh, small pictures you can see. So it basically saves time. So when you have many different parts to renumber, and operations are made at the part level and applied to all instances of the part. And the second update is basically, the third update is basically query using the local coordinate system. So when you want to measure the distance between 2 points or nodes, or you want to find the geometry face normal or element face normal, so it always used to happen in the global coordinate system. Now we can select a local coordinate system as well. So based on that local coordinate system, the distances or the other query output will be given in the message window. So this is a big update. I know many people who are using Python regularly for Abaqus automation or the scripting purpose. They always used to have issue with the plotting. So right now the matplotlib is included in Abaqus 2020. So you can do a lot many plottings when you are doing the post processing part especially. And also the SciPy, SymPy, these things are upgraded. Now the Python version is upgraded from the older version to 2.7.15. So this is probably not till now in the 3-point version. So it is still now in the 2-point version only. So this is another one advancement. You remember probably when you used to do some kind of assembly operation, like you're having some kind of bolt or some kind of interference speed. So in that case, we do import analysis. We basically do the contact interference analysis in the Abaqus standard, and then we bring that result in the Abaqus Explicit. But right now, the contact interference can be solved using the string fit analysis in Abaqus Explicit as well. So this is supported both in the GUI and the keyword level. So this is the example what we are saying here. Now you can launch the standard test from C for hyperform material behavior. So it's similar like what we used to do for the hyperelastic or viscoelastic material or the isotropic elastic material, but this is now supported for hyperform material as well. So that means you can do the calibration in the calibration tool of Abaqus CAE for hyperform material. And this is one additional update which is color code by geometric cells and faces. This is applicable both in the part and the assembly module. That means if you are having multiple cells or faces, if you want to identify them by color, so you can do the color coding automatically in the Abaqus CAE window. Animation in the linked viewport manager. So when you are having multiple viewports and you are trying to animate different plots or different kind of uh, deformation pattern, so generally you are not able to do the animation in the both the part at the same time. So the viewport manager actually allowed that thing to be done. So that means you can connect two animations all together in multiple viewports, and they can be animated together in both the viewports. And this is another one update, eliminate model instance restriction in assembly. So model instance can now be used with instead a linear pattern or the radial pattern or the replace pattern. So this is the model instance, not the part instance. So part instance used to be supported previously, but now it is supported for the model instance as well. This is additional one very useful update. So when you are having two different kind of similar model, just a few of the differences in the geometry. So sometimes you want to copy the constraints uh, and few of the interaction behavior. So in that case, you can directly copy the model object, basically the constraint also from one model to another one. And this is the handedness and the normal adjustment for bolt clearance. So this is supported from the Abaqus 2017 version itself, but a new support for the parameter for standard surface to surface contact is added in this case in 2020. And this is one quick overview of what you can, how we can visualize the 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 different kind of loads or the boundary conditions which are active in a particular step. That is through the color coding. So the green color basically so that these particular steps, sorry, these particular loads or the boundary conditions are propagated or created. And when you are having a little bit of reddish color, that means that particular load is deactivated, and the yellow color basically so that that particular boundary condition is modified. So the color coding will give you a quick understanding of which particular load or boundary condition is modified, propagated, or deactivated. So it is very much useful when you are having multiple load steps. And this is hide over or under limit values from control legend. So this is very simple, as you know, like sometimes you want to create a legend where you don't want to show the over and the under values, the maximum and the minimum value of the control legend. So that one we can do now. So now I'll be going to the quick material and element enhancement. So here, so there is nothing as such like a new element has been introduced, but few of the element behavior or the material behavior is been updated and enhanced. So one thing is the tensile failure for the material. So you can use a tensile failure for a particular kind of Johnson-Cook plasticity model. Uh, so tensile failure sub option is now available for the equation of state material behavior as well in the Abaqus CAE. So this was previously available through Abaqus keyword interface, but right now it is available in the Abaqus CAE interface as well. So this is a good update, I'll say. So as you know, like C3D8R or the C3D8, the full integration or the reduced integration, they somewhat steep or very much, I mean to say, soft. So C3D8I shows very good behavior when you're having different kind of loading scenario. So that C3D8I was not available in the Abaqus Explicit analysis previously. So now it is included in the Abaqus Explicit. So you can take the advantage of this element. So basically, it will not uh, uh, induce any kind of hourglassing issue. so which you can see in the reduce integration element. And once again, this is not a full integration element, so that means it will not give you overly stiff behavior. So in that sense, you'll be getting a very good accuracy of the result when you are using the C3D8 element in the Abaqus explicit analysis. So few of the elements which are added, so like coupled temperature displacement cohesive elements. So these can be used for fully coupled thermal procedure. So that means if you're having a structural thermal problem and you want to use some kind of adhesive material which will be having both the thermal and the structural behavior coupled together, so you can use in that case. So element type DC3D5, which is like 5-node linear pyramid element, is now available in Abaqus standard, which was not previously available. And CR panel CR4 element is available now in Abaqus standard. So this is useful for the composite material. So these are few of the updates which is in the contact enhancement. So if you see here that we are basically given the updates in the tabular format, but I am going to discuss only those updates which are basically a new functionality in Abaqus 2020, which was not even available in the 2019 of FD FD release as well. So this is like interference speed capability in Abaqus Explicit, which I've already discussed previously. So this is already included in Abaqus 2020 through CAE. And contact initialization using the Abaqus Explicit. So these are the most important two different contact enhancement. And apart from that, few of the enhancement like the new bond state of C status output, uh, and the enhancement to cohesive contact behavior with cheap or permanent bonds. These are few of the additional update which probably many user uses. So I'll just give you a quick overview of how the results look like when you're using these kind of facilities. So this is one example where we are trying to compare the Abaqus explicit and Abaqus standard result of the sync field interference speed. So you can see they pretty much match together. So that means if you're having lot many assembly load where you want to apply the interference speed in the first step of Abaqus explicit, you don't need to do the import analysis once again. You can do the whole analysis in Abaqus explicit itself. So we can see the result comparison between the von Mises stress the contact zone as well. So they are matching nearly, but it can show somewhat a little bit of uh, uh, a stress concentration issue in the Abaqus explicit if you're having some kind of very sharp corner in the interference zone. So keyword previously was applicable only in the Abaqus standard for the contact initialization or the contact initialization assignment. So now this is also relevant to the Abaqus explicit. So that means we can directly define the contact clearance to Abaqus explicit itself, and this is how the keyword looks like. The people who are using the keyword interface Abaqus, they already know these things, but what I'm trying to say is that we can include these particular additional updates in Abaqus explicit analysis as well. So specifying an interference speed example I'm showing here that differs from the initial configuration. The initial overclosure distance of the part is like 1.25. So you can say like the contact initialization name, uh, the the particular interference name and the interference value, and we will be searching below 1.3. So then Abaqus basically try to adjust that particular value 0.4, and apart from that, whatever the value is there, that will be trying to remove as a overclosure. So 0.4 is basically what is the interference. Okay, and apart from that, the additional value is basically done to the strain free adjustment. The node will be adjusted without adding any additional stress to the part. So this is one very good update. Okay, so which is basically uh, the the contour of the contact status. So previously it was like either closed or open. Okay, so now it is closed, open, and also bonded. So this is like sticking, sleeping, and open and bonded. All these four different status of the contacting areas you can directly identify by seeing the contour. So this is applicable both in the Abaqus standard and the Abaqus explicit. And this is a convergence improvement of vertex to surface uh, uh, contact for the cohesive zone. So here is basically example you are seeing here. So there is no such severe discontinuity iteration is happening, and equilibrium iteration increases with load magnitude, but you can see that the performance is increased quite a lot from the older version of Abaqus. And this is one thing which I always eager to see, but it sometimes makes sense and it sometimes doesn't make sense. Like adding uh, the thermal expansion in the rigid body. So if you're having a rigid body, so if you want to include the expansion because of temperature change in the rigid body, so you can include that one as well right now. Okay, so this is basically the equation how the rigid body is calculated based on the moisture and the slave nodes. But sometimes, in many cases, when people are defining a rigid body, they mean to say that this part should not have any deformation. But when you are using that particular rigid body in the model where both the thermal and structural coupling is happening, so probably you want to incorporate the rigid body expansion as well. So in that case, it will be probably useful. So this is linear dynamic updates. I have not included many of the updates in this linear dynamics. So as you know, like the modern finite element technology includes a lot many diverse kind of element library and advanced material model and sophisticated constraint capabilities for modeling the linear dynamics problem, especially the direct matrix input and the substructure. So these are two areas where Abaqus 2020 has done a lot many updates and upgrades. So it is having now rich material level and system level damping capabilities that I'm going to discuss in the next slide. And you can get lot many various output options, including specific linear analysis feature like acoustic contribution factor for the coupled structural acoustic analysis, energy flow for the frequency response, or the RMS noise stress in the random response analysis. So these outputs are not previously available. So those are incorporated in Abaqus 2019 FD version, but now these are available in 2020 GA version as well. Also, there is a huge performance gain happened in the combination of multiple CPU core or the hybrid solving scenario exactly. So now we can define the damping capability in the frequency domain analysis. So previously it was like material level and the element level you used to apply. So now we can apply the sub-assembly level and the system level. The C and S value, these are the two different kind of damping which is included in the Abaqus 2020. So the C basically includes the FE, the damping of the FE model, the global and the C model. Okay, so the C global is basically once again a material damping and the stiffness damping, so alpha and beta, and the C model is basically M5 D5 transpose M. So this is basically diagonal matrix. Okay, so this is basically you're defining the damping based on the modal frequency and the mode participation factor. And the structural damping once again consists of the FE damping and the global damping and the modal damping. So where you can define the global damping to be a value like gamma global into K, so which is dependent on the K value. And the S model is once again M5 G5 transpose M. So G is once again a diagonal matrix. It's basically a system level damping definition. So these are different kind of energy output in the frequency response analysis for direct and modal linear dynamic analysis. So you can now reduce the kinetic and the potential energy, which can be given in a way like cyclic mean values, then amplitude and peak values. Even you can plot the different kind of energy like external work, viscous or structural damping energy loss. So you can total integrated value over the time. So in that sense, you can see when you are applying certain kind of load. So what kind of energy gain is happening in the system? So you can do the history and printed output of the integrated energy value of the whole model or its part. So this is very useful scenario for the uh, for the model analysis. So many people ask the energy output in the part level. So that is very much quite useful, which is the integrated energy value in the part level. And the field output like element by element energy density or energy for the whole model or its parts. So energy output of eigenmodes like normalized potential and kinetic energy. So cyclic mean value for the parts in the model defined by the elements is. So this is somewhat useful. Like if you know that for a particular part, you are doing a eigenvalue analysis and see that one particular eigenvalue is having a huge effect on the response of the system. So in that case, you can find for that particular mode which is the position where you should do some kind of strain gauging to see that that location is having the maximum amount of strain induced in the model. So this particular output will give you that kind of indication. So element by element normalize potential or kinetic energy of the energy density in the cyclic mean value. You can get these values. Energy and power flow in the frequency response analysis. So how much energy flows through a given node set into a given element set. This is very important energy output, which will give you lot many indication about the transfer path. And acoustic radiated power, energy and power flow into the acoustic domain from a given panel defined by a set of structural nodes. So if you're having a uh, a couple structural acoustic analysis, and if you want to see what is the power that is coming to a particular panel because of the acoustic coupling, so that particular energy output will give you that indication. So this is one enhancement for the performance of the uh, eigenvalue extraction and the SSD analysis. So for a 10.5 million degree of freedom, which is having 3.6 million nodes and 1.5 million elements, and use a and in the benchmark test we have used AMS eigensolver, and we are requesting for 1750 eigen modes with full recovery of strain energy field output for all eigen modes, and SSG with 200 frequency points and 7 load courses, and displacement field output for the whole model. You can see how the performance gain is happening compared to the 2019 GA version to the 2020 GA version. So 2019 HF2 is basically once again coming in the 2020 GA version. So there is a huge performance gain if you see the the value in the Y column, which is basically the time taken to solve those particular class of problem. Even if you're doing a SSD register analysis, so there is a quick gain in getting the final result in the latest version of Abaqus solver. So this is one of the output where we know like many people are using the matrix output for a particular part. So they basically create a matrix which basically consists of multiple nodes and elements. And what the problem is that once they get the particular matrix, they were not able to translate, rotate, or reflect or specify a particular Euler angle. So that means every time uh, your rotation or the orientation is changing, you have to recreate the matrix. But right now these matrix can be directly rotated or transformed into different kind of orientations or the positions. Okay, so this is one very important output where you'll be using the star matrix assembly option to define what is the translation, rotation, reflection of the Euler angle value for the particular matrix. And this is a enhanced functionality available in the Abaqus 2019 hotfix 2 version itself. So this is anyway available to 2020 GA version as well. So we are basically when you are having some kind of DMIG matrix data in the bulk data format. So if you want to translate that one from Neston to Abaqus, so that one can be done directly, and even the vice versa is possible. So that means you can translate from Abaqus to Neston translator as well. And now we'll be going to the updates in the Abaqus Explicit. So in Abaqus Explicit, so there are basically three main updates which we'll be discussing in this particular webinar. So I think these are the outputs where many people faced a lot many problems in the previous version of Abaqus. One thing is the distortion of the reduced element deletion, and second thing is a linear kinematic conversion for the continuum elements. So in this case I'll be giving you few tips and tricks like how you can resolve this kind of problem and gain a huge performance in solving a particular class of problem in Abaqus explicit analysis, and definitely what is the improved CTD8I kinematics, which I've already discussed previously. So I'll just go through these things very quickly. So if you know, like when a material undergoes extremely large deformation, so the element will become distorted so that the volume of the elements become negative, and this may occur that without the material reaching to a failure criteria, so your Abaqus will be either getting a fatal error or it will be directly getting aborted. Okay, so in that case what it does is that it write a element set which is like one element distortion deletion set. Okay, and by going through the uh, aborted ODV file, you'll be able to see where exactly the element distortion happened, but you really can't do anything on top of that. So either you have to add some kind of artificial stiffness to the element, or you have to use some kind of element deletion so that that element get deleted and the analysis continued. But right now what the additional update they have given is that you can define a particular value of stiffness value. So once the element is basically going extremely large deformation and the deformation is becoming unrealistic, so in that case it will be having a particular kind of stiffness value so that the element don't behave uh, in different ways so that the element will be having a negative volume issue. So in that case what will happen, it will be behaving much more in a linear fashion. So those who don't want to use the element deletion criteria, so in that case it will be very much useful. So in that case, if you go to the keyword interface, you'll be seeing like the section control, and you basically say distortion control equal to yes, and then you give a length ratio with IR value and the linear kinematic conversion, which is the IKC value. So this linear kinematic conversion is the additional option which is available in Abaqus 2020. And many people have faced this problem, especially when you are doing explicit analysis, and because of load and the way you have defined the material plasticity, that it is going in the perfectly plastic state. So in that case, the material loses its stiffness value after it's reached the highest strain value. So in that case, it start to become extremely distorted shape. Okay, so those particular cases you can resolve by using a linear kinetic conversion value, a particular stiffness value. So additional incompatible modes were implemented in Abaqus Explicit to make the formulation consistent with Abaqus standard. So that means if you are using some kind of C3D8I element in Abaqus standard and you want to import the part in the Abaqus Explicit, that one can be done. And even for a improved accuracy of the result, so if you are having lesser number of element along the thickness direction, to reduce the hourglassing issue, you can use this particular C3D8I elements. Also, it removes the bilinear pattern in hydrostatic stress for approximately incompressible materials, and its import now fully support. The import is now fully supported for C3D8I between the both explicit and standard, which I've discussed, and there is an issue with the mask scaling, so that is also been fixed in for this particular improved C3D8I elements. So this is one scenario where people who are mainly using the coupled Euler and Lagrangian option for solving a high pressure gradient fluid flow or high flow rates or surf corner on structural mess or large motion of structural mess, or in the case when you are having kind of blast analysis. So what happen in those cases is that if you're having a surf corner or high pressure gradient, so you'll be seeing that some of the liquid or the Eulerian domain is starting to leak. Okay, so previously what we used to do is that we basically used to do some kind of addition in the environment variable to change the default behavior of the leaking. So in that sense, we used to remove the leaking of the fluid portion. But right now, with the with the additional enhancement in the CL contact formulation, so this particular leaking of the liquid gas will not happen. Okay, so this can be used for both the solid and the cell structural surface, and structure should be thick enough to avoid multiple surfaces intersecting the cell Eulerian elements, and leakage may still occur where a single Cl element is intersected by multiple surfaces. So this is one scenario where you need to be very careful. Okay, and self surfaces must have different material on the opposing sides, and the enhanced formulation is more expensive than the default formulation in both CPU time and the memory uses. So the keyword interface is basically the star adaptive mesh refinement, then element set, and then you basically say enhance contact equal to yes. But remember, this particular option is not required unless you are having a fluid leaking issue. So to show few of the issues here, you can see the previous version of Abaqus and the new version of Abaqus. So it's basically a rigid tank with a gas inflator. So that means when you are increasing the pressure, the gas is going to expand. So in the old version is basically in the left side, and the new version is basically, sorry, the old version is basically the right side plot, and the new version is basically the left side plot. So if you see in the left side plot, in all the instances of the plot at at time equal to like 0.058244 and other different values, you see that in the right side plot, the fluid is starting leaking at the point t equal to 1.3582 per minus 3. So after a certain time, you'll be seeing like the tank is fully I mean to say void, so due to the leakage issue. So this issue is now solved in Abaqus 2020 with the enhanced contact method. So in that sense you can take the advantage of this one, and even in the blast analysis you can by default switch on this particular option to get a better kind of uh, CL behavior. And this is one very important update, and many people really don't understand this point, that when you are having multiple kind of constant defined, it could be rigid constant or some kind of kinematic coupling. So in that case, or some kind of tie constant, so what happen is that if a particular node is shared by different kind of constants, so they try to resolve by themselves so that there is no over constant. Okay, but in explicit analysis, for resolving this tie constant or different kind of multiple constant, you basically use the implicit solution method, where what it does is that the explicit creates a stiffness matrix that is solved using Newton's method, and it causes significant performance penalty depending on the sizing of the matrix, and the memory requirements also increase, and it degrades the load balancing and then negatively affect the parallel performance. So if you're solving in multiple CPU, you'll be seeing there is a huge slowness in the solution. Okay, for this kind of model where you're having lot many constant defined. So these situations occur mostly in the boundary condition and dependent nodes overlap constant like tie, coupling, MPCs or connector elements, or using nodes of a rigid body as a dependent nodes. So what is the resolution for that is that you need to go to the ODB and just search for star const CONSTR star. So once you go with that, you'll be getting the set names of these kind of names. So you should check which names are having a value like underscore ELEM and underscore ELIM. Okay, so when you are seeing that underscore ELIM, that name indicates that the constraint that is the elimination solution technique have no other constraint. So this is a very really good option. This is really good. So those particular elements you can easily ignore, but those elements set where you are saying like underscore element underscore, so that name indicates that they have some form of over constraint and are solved implicitly. So this is less good, and highlight these in the model to see where that is exactly happening, and then you change your modeling approach. You try to reduce the number of underscore element underscore nodes to minimum value. So what can be done, you can flip the slave and master in the tie definition, or you can insert a deformable element to break the connector chains, or you can replace a rigid body with deformable body, or you can replace a tie with a cohesive contact. So these are the options by which you can convert this maximum of the surface of the sets which are having underscore element underscore this particular set to underscore ELIM underscore. So in that case, you will be able to remove maximum of the over constraint and will be completely eliminating the implicit solution technique in the explicit analysis. So in that sense, you'll be getting a huge performance gain. And this is very much useful when you are having lot many constant, if you're having a very big model, where you're having a lot many tie constant as well. Now, this is one of the very important update for the people who are involved in the IT configuration. Okay, so here basically that when you are using a FlexNet license file and when you are upgrading your Abaqus version for the end user, so make sure you are getting a new license which will be supported by Abaqus 2020. So basically, you should check the we should open, if it is a FlexNet license, you can open in taxpayer and you should check what is the Abaqus LM version. That should be 62.1 to support the Abaqus 2020 working with this particular FlexNet license server. And the process is quite known to maximum of the people who constantly uh, handle the license server. You basically back up the current license file by saving with the new name and copy the new license file in the same location and rename it to the actual license name, and then you run the FlexNet licensing tool and you stop the FlexNet and restart the Abaqus license server. Then it will be reading automatically the new license. So this is quite known to many people who are regularly handling the uh, license server. And if you want to download the Abaqus latest version, so you can go to www.software.3ds.com, and with your DSS client credential, you can log into that. And if you have Abaqus in your portfolio, you can download directly the latest version from the software.3ds.com. And few of the key changes which are incorporated in the in the installation process is that so from the previous installation of Abaqus 2019 to 2020, there is not many changes happen in the installation phases, but I'll say it is much more for the advantage of the end user. So one thing is that multiple Simulia established product have been combined into a single installation. So that means uh, so the Abaqus, EFISAP, Tosca, they are combined together in a single installation. So that means you will not be getting multiple folder for the Abaqus iSight, sorry, Abaqus Tosca and the EFISAP, but definitely iSight is still now in a different folder. When you are installing, it will be creating a different folder. But however, into note that the CAE media, which is basically used for user subroutine and the post-processing program, is still provided as a separate installation step, and iSight media is still provided separately. So iSight must be installed into a separate target directory, and the Simulia established documentation is still provided separately. So if you need the cloud view or the search dog or the documentation option, so you need the cloud view license, and this must is be installed in a separate directory. So you can install them in the same directory. So due to the product installation consideration, the number of installation media or chip space has been reduced to 4. So previously it was 5. So now if you want to download the Abaqus 2020 version, you'll be seeing 4 different zip file. Okay, so the media size and the complex installation size also has been reduced. The complete established product installation can be removed in a single step, not including iSight. So if you want to remove the complete product like the Abaqus, EFISAP and Tosca, so previously used to remove them one by one by going to the add or remove option, but right now we can remove in one step itself. The default target directory for the Simulia established product is changed now. So previously it was in the C Simulia, then CAE, Abaqus CAE, then different version was there. But right now it's like C Simulia established product, and then 2020 for the Windows, and for the Linux it is used as Simulia established product 2020. So the Windows program list contain the single entry. So previously what you used to see for, if you see in the right side, the picture of my start menu. So where you can see that the Dassault Systems Simulia established product is basically combine of Abaqus CAE, EFISAP and Tosca all together in the same directory. So previously for Abaqus CAE, for EFISAP and Tosca, they used to be in different start menu directories, but right now they're in the same directory. However, the iSight is in different directory. Okay. So the Simulia established product installation no longer prompts the user for the documentation location. The products are now configured to use the Simulia established products online documentation by default. So if you are having a local installation documentation, then user can manually reconfigure the documentation post install. So after installing, you need to uh, go to the environment variable. There you can directly reconfigure it. So the logs are generated under the product installation folder, install data and log. So these are basically the default installation folder uh, of the log files. So in Windows, you can see in the established product 2020 install data log, and in Linux, similarly, you can see in the other folder what is mentioned here. So now I'll be going to the quick summary of the whole updates, whatever we have discussed right now. So basically, the updates in the Abaqus says that the partitioning of cell by extrude sweep of the edges has been changed now. So you can use now close open chain of edges as well. Now you can directly import the SolidWorks parts. You can use a local coordinate system to display the results of queries such as point and instances. You can renumber the nodes and elements on parts by selecting from dependent instances in the assembly context itself. The CRPN element can now be assigned in the mesh module. Abaqus CAE now support contact initialization data and assignment for Abaqus Explicit. And you can synchronize the animation across multiple viewport. And when you are modeling or managing the model objects, so basically you can copy different kind of objects like constraint between the models from the current model database. You can do the color coding of part and assembly by geometric scalar faces. Even you can use the color coding tables in step dependent manager across to the object status. You can hide the actual minimum and maximum values from the control legend when you specify minimum and maximum value for the control plot. So these are the enhancement summary in the analysis phase. So there are substantial computational performance gain is achieved for linear dynamics procedure. You can now do the translate, rotate, and reflect transformation to define the position of the matrix subassembly. Several enhancement to the steady state transport analysis is included here, though I haven't mentioned in the presentation, but I have included in the summary phase. So basically, people who are basically working in the tired domain, they knows that the steady state transport analysis is required to rotate the material through the mesh. So in that case, what you do is basically is that when you're having different kind of unit system, or even the performance is basically somewhat objectionable in previous versions. So right now this functionality is having several enhancements, so that means you'll be seeing a huge performance gain in the solution time as well. So Abaqus provide the capability to transfer the model data and results of element sets or part instances multiple times from Abaqus Explicit to the Abaqus standard. The default iterative solver controls are now changed to improve the solution accuracy and nonlinear convergence pattern. And new energy variables are available in the steady state dynamic analysis and in the eigenfrequency analysis. The improved performance is achieved for recovering the nodal results for the computationally intensive model summation methods available in the response spectrum analysis. So these are some of the enhancement in the elements, like distortion based element deletion, the cell element deletion based on the integration points that are now available in Abaqus Explicit. Symmetric modeling using cohesive elements is now available in Abaqus standard. So the thermal expansion of rigid bodies like kinematic coupling, beam, MPC or link MPC can be incorporated. In the interaction, you can have the small sliding tracking approach for the general contact, so which was not previously available. Abaqus explicitly enhanced to resolve the initial overclosure as interference speed. Contact initialization is applied once again in the Abaqus explicit, and Abaqus standard has improved accuracy and convergence behavior for the steep or permanent cohesive bonded contact with general contact option. And definitely in the contact status output, you can see additional plot of the bonded status as well. So the output is basically in the mostly on the energy side. So in the steady state transport analysis, you can request for few of the additional output like SST-IF or SST-IRF, SST-IRM. So these are basically in the steady state transport analysis. What are the different kind of output which you can get from the Abaqus. And if you are using user subroutine, the table collection functionality previously available only in the Abaqus standard, but it is now available in Abaqus explicit as well. And one of the very I'll say the demanded upgrade is basically including the matplotlib in Abaqus Python, so which is pending for long time. So right now it is available in Abaqus 2020, so you can take the full advantage of this one. Now few of the additional functionalities like people who are into the additive manufacturing process simulation, so the documentation is available now, and also the lump kinematic molecular method is available for the airbag deployment analysis. So with this, I'll end my presentation. So thank you very much